Well, welcome back, guys. We're now into the desert. I hope you enjoyed Dr. Alford's lecture on the desert and what it is that animals and plants have to adapt to within our desert, and particularly our Sonoran Desert here in Arizona. We are going to now start looking at particular animals and plants and looking at how they particularly adapt to the desert. There are a lot of animals and plants that live within the desert, and of course, we can't cover them all in this class. I have chosen a select few that are kind of more interestingly adapted to the desert per se. So today, this week, week 8, welcome to halfway through your class. We are going to look at amphibians and reptiles and how those little buggers are adapted to the desert. Our week 9 will look at mammals and birds and how they are adapted to the desert, and then we'll move into 2 weeks of plant adaptations to the desert. I'm excited because you are very soon going to be taking your own little hikes out into the desert and doing some desert activities of your own, so hopefully you enjoy hiking and enjoy looking at animals and plants out in the desert, because we're going to be doing that over the next 4 weeks. So let's talk about some amphibians and reptiles. So first of all, we need to think about, what do we know about amphibians and reptiles? Amphibians were one of the first to evolve to start moving out of the water. They are earlier and more primitive than the reptiles, and they never got fully out of the water. Reptiles came after them and were the first ones that were fully out of the water and able to adapt to living completely on land. So let's think, amphibians in the desert. That was a really strange, interesting concept to me, because amphibians are tied to water. So let's think, back to Dr. Alford's lecture, what do these animals need to overcome? Okay, so he looked at, we have obviously extreme heat. In some deserts, we also have fairly extreme cold. So potentially, at night, they have to adapt to cold. During the day, we know here in Phoenix that we have to adapt to extreme heat, particularly in the desert, where it even gets warmer than it does. Obviously, we can go into the air conditioning. These animals don't have that opportunity. So they have to adapt to extreme heat. And then they also have to adapt and or avoid or escape what we call desiccation, which is drying out, basically lack of water in the desert. That intense sun basically sucking the water out of their bodies. That is one thing that they have to adapt to or avoid and escape. So let's think about amphibians. So what we know about amphibians is that they have partially adapted to living on land, but they are still tied to water. Okay, they are tied to water because their eggs are laid in water and their larval stages grow up in the water. Tadpoles, I'm sure you probably played with them when you were a kid. So tadpoles, their larval stages grow up in the water. Adult animals are still not fully adapted to being out of the water. They have breathable skin, what we call permeable skin, which allows oxygen to exchange across that skin, as well as absorbing some water across that skin. So amphibians cannot live very far away from a water source. Okay, so let's think about the desert. Do we have water sources in the desert? We do have some water sources in the desert. Generally, you're going to find amphibians near permanent ponds, streams, springs, things like that. Not always. They do tend to get a little bit further away from water, but if they do that, then they have special adaptations to help them adapt to being away from the water. So let's look. Amphibians evolved prior to reptiles, as I said. They were working towards a terrestrial lifestyle, but they never made it completely. Okay, eggs and larval stages are aquatic. Terrestrial living for the adults, but we still have that breathable skin. So their air and water is exchanged across their skin, so they need to be tied to water. They either need a permanent water source, which there are some permanent water sources in the desert, or they need to take really quick advantage of temporary pools that are created during these monsoon rains we have in the summertime. Temporary pools of water may be created, and that allows them to suddenly come out of avoiding, jump into the water, breed really quickly, and have their tadpoles grow up really quickly before these temporary water sources disappear from, once again, drying out. So 2 different strategies: either live near permanent water or breed really, really quickly. So let's look at some examples of amphibians. We actually, interestingly, our Sonoran Desert here in Arizona is actually fairly diverse in amphibians, which was a very surprising fact to me. There are 25 native species of amphibians in the Sonoran Desert. 24 of those are frogs, and we have 1 salamander here native to the Sonoran Desert. Their solutions are to avoid, escape, or to tolerate the conditions within the desert. And as we can think, probably most amphibians either avoid or escape because they are not really able to tolerate very well due to their permeable skin. So let's look at some examples. This is the barred tiger salamander, our 1 native species of salamander here in the Sonoran Desert. And these guys are actually kind of interesting because they actually remain what is called neotenic. Neotenic salamanders actually retain their larval state. They never fully mature out of that larval state, which allows them to avoid the harsh conditions outside on land because it means that they live in water all of their lives. If you look at this guy, he looks very similar to what you would think of potentially as a tadpole. He still has a tail, but he's got legs. He's got gills that he breathes through. So he lives in the water, and yet he is an adult and can breed fully as an adult, but they permanently live in a pond, stream, or spring, which basically with these salamanders allows them to completely avoid the harsh desert conditions altogether. Now, not all tiger salamanders remain neotenic, but some of them do. The next one we're going to look at is what is called the desert spadefoot toad. And this guy is got some really interesting characteristics in how he adapts to the desert. I actually have a video in week 8 of an African species of similar toad. I believe it's African, and we're going to look at that video and look at how these guys basically spend almost their entire lives buried under the ground and then come up right when the water is available, do their breeding, eat their food, and then they go back underground for the rest of the year. So kind of interesting. They live in burrows almost their whole life. They live in burrows that they dig themselves. They're called the spadefoot toad. So actually their back feet are adapted to be similar to spades. So they have these membranes sort of on their back feet that make their feet wide and able to dig very easily. So they dig these burrows and they spend almost their entire life in them. While they're in these burrows, these guys actually can secrete a semi-permeable membrane that goes around their skin, basically kind of like a shell almost, putting themselves inside an egg sort of, but it's semi-permeable, secreted from their skin, and this semi-permeable membrane thickens their skin and allows them to avoid water loss. At least that's what it's believed to do. So kind of interesting. They're hanging out in a burrow with this kind of mucousy sort of semi-permeable extra skin around them for almost their entire lives. The other adaptation that they show is that they have developed a high tolerance for urea in their system. Okay, urea and uric acid wastes are the things that are left over from the water and the food that we process, basically what we would call urine, and they don't excrete the whole time that they are in their burrow. So these uric acid, uric wastes are building up inside their bodies the entire time that they are in their burrow. So their body has developed a tolerance. Generally with us, if say our kidneys weren't working and we couldn't eliminate uric acid waste, urea from our body, it would become toxic to our system and we would potentially die from that. Hence we have dialysis when our kidneys are not functioning. Well, these frogs actually, their tissues have developed a high tolerance to this urea building up in their body so that they can let it build up while they are hibernating, estivating, whatever it is that they're doing in their burrow, and then they eliminate it once they have come out of their burrow. which is kind of an interesting. So I have here a picture of their back feet. You can see that it kind of looks like a little bit of a shovel, okay? Webbed feet, really wide, really, really good for digging, okay? Modified back feet, these burrows may be as deep as 3 feet. So that's really, really long. These are deep burrows. These frogs are serious diggers. And they remain in these burrows 9 to 10 months of the year, avoiding, okay? So their strategy is to avoid. Once the rains come in the monsoon season in late summer, they come out to breed and eat and back in the dirt. So I called this slide Thunder Down Under, which I think is kind of interesting because what tells these frogs when it's time to come out of their burrow potentially and breed? They obviously have this limited time to take advantage of these temporary pools from the monsoon rains. And so is it moisture seeping down into their burrow that indicates to them, oh my gosh, there's water, it's time for me to come out and breed? Well, interestingly, it's not. Thunder Down Under, it is thought that these animals detect vibrations or noise. So potentially it is the noise or the vibration of the rain pounding on the ground. You've been in some of these monsoon storms where it's just absolutely pouring. So the rain pounding on the ground, or potentially the sound of the great big thunder cracks we get during these monsoon rainstorms, those sound vibrations are what kind of startle the frog and go, oh wait, there's a storm going on, I need to get out of here and get my business done. So kind of interesting that they sense vibrations and not necessarily the moisture that is coming down from the rain. So what those vibrations indicate is that there are going to be pools for them to be able to breed available. They are temporary and they need to get out, they need to breed and eat very quickly. Interestingly, a spadefoot toad can consume enough in one meal to last the entire year. Hibernation, estivation, when they're down in these burrows, their metabolism slows down quite a bit and their digestion slows down. I talked about their elimination slowing down. So they can eat enough food in one meal. They just gorge themselves during this period where they're above ground, and that food is enough stored within their body to feed them for the rest of the time that they're in their burrow for most of the year. Interesting. The other interesting fact about the spadefoot toad is that they have developed a system of accelerated metamorphosis. Okay, metamorphosis, big word. That's a word that basically means change of shape. Okay, so butterflies, caterpillars go through metamorphosis to change to butterflies. Frogs go through metamorphosis to change from tadpoles to frogs. So these guys have an extremely accelerated metamorphosis. So once again, amphibians generally tied to water, they lay their egg masses in water in these temporary pools, okay? So on the left here, you can see an egg mass. The eggs in this particular species can hatch out within 15 hours, okay? Most non-desert adapted frogs, it takes 6 to 21 days for those eggs to hatch out. So 15 hours versus 6 to 21 days. Very, very quick hatching process for those eggs. Then we get to the tadpoles, okay? So the tadpoles emerge from the eggs. This organism in particular can go from egg to froglet. Froglet is what you see here at the bottom where they still have their tail, but they're basically like a miniature frog. That can happen in as little as 2 weeks. In a normal frog, that metamorphosis process generally takes 12 weeks. So very, very quickly, they can go from egg to frog, who then can live outside the water and go underneath the burrow and preserve their water and live as an adult frog within the time of about 2 weeks. And we all know, having experienced monsoon rainstorms, that when these really big ponds, we get huge rains, the ponds can last for up to 2 weeks. Because our soil is so compact, the water really doesn't drain out very quickly, and so these pools last for, a couple of weeks. And these frogs take advantage of that, and they have this accelerated metamorphosis, which allows them to rely on these temporary pools. Moving now on to what we call the northern casque-headed tree frog. There are other names for this frog, but This one also is similar to the desert spadefoot in that it has back feet that are spade-like and so adapted for burrow digging. Interesting, pay attention to burrow digging. In amphibians, generally the amphibians dig their own burrows. In reptiles, generally they take advantage of burrows that are built by other animals, mammals, things like that that have been abandoned. So maybe reptiles are a little lazier, I don't know, but amphibians are the ones that are digging their own burrows. So these casque-headed tree frogs are also digging their own burrows. It was interesting to me that I think about tree frogs living in the rainforest. So it was interesting to me that we actually have some tree frogs here that are adapted to living in the desert. So another adaptation, living in the burrow. It's different than the spadefoot frog. This one, they actually shed the outer layers of their skin. So it's different than that semi-permeable membrane that the spadefoot toad had. This time they actually shed the outer layers of their skin. And these outer layers of skin basically make kind of a cocoon around them while they're in their burrow. And this basically allows them to protect themselves from the water inside their body basically drying out within that burrow. The other thing that these interesting casque-headed tree frogs do is when they're in their burrow, they block the hole of their burrow with their head. So they basically shove their body up against the hole of their burrow and their head fills that hole. And that basically traps humidity inside that burrow and keeps the humidity from being able to escape through the opening to their burrow. It also protects them potentially from predators because predators aren't able to get into that burrow because their head is just basically like blocking the door. So pretty interesting little frogs. The western barking frog, another interesting. This one is actually really interesting because it is a truly terrestrial amphibian, which is kind of strange. We don't really think about amphibians being able to go completely away from water. This one is called the western barking frog because of its call. We've been learning about frog calls in the last couple of weeks and the difference in frog calls and how females are attracted to their particular species of frog call. So this frog call sounds a lot like a barking dog, and so that's why they call it the barking frog. And this frog has actually been able to adapt completely to a terrestrial environment. These guys generally do not live in burrows. They don't dig burrows under the ground. So this species potentially is more of a tolerator than an avoider, okay? Which is kind of surprising within the amphibian group that one can actually tolerate the system. So they don't live in burrows, they live under rocks, sometimes in caves or deep wells, things like that. Obviously in the shade because they can't be out in full sun or that would really completely dry them out. So, but they do live under rocks and in caves. Caves, you've been in caves, probably usually dripping wet with water. And so caves are very, very humid, so that would be a potentially good place for an amphibian to live. Also breeding at the time of the monsoon rain. So males are calling for the female at the beginning of the monsoon rain. And these guys actually do not lay their eggs in water. They actually lay their eggs in either moist or rain-filled rock crevices. So finally an amphibian that got completely away from water and can lay their eggs on land. So even if it's just moist, even if it's not rain-filled, they lay their eggs there. Well, these eggs are interesting. They are much larger than normal amphibian eggs, and they have much larger yolks within them. And this is important because this frog does not have a larval stage. It doesn't go through an aquatic tadpole stage. The frog develops completely within the egg. And so that larger yolk is used to provide food for the froglet while it is still inside the egg. And then once the egg hatches, a mini frog basically comes out. So these guys have actually been able to get themselves completely away from water. Interestingly, the male frog, go men, ladies, male frogs are the ones that guard the eggs in this situation. And the male frogs also secrete fluid from their body that keeps the eggs moist. So males hang out, secrete fluid from their body, keeping the egg moist. And they go through direct development, where they skip that larval stage, and the frogs actually basically hatch out of this egg about a month later. So they spend a longer time within the egg, but they skip the larval stage altogether. So kind of interesting that we have an almost completely terrestrial amphibian. All right, so those are some examples of amphibians that are particularly adapted to the desert. Obviously, all amphibians are somewhat adapted to the desert because they're amphibians living in the desert, which is pretty surprising to begin with. But most of them are tied to permanent water sources. So let's now move on to reptiles. And the reptiles were the first to truly colonize land evolutionarily. We know that. They were the first to develop bodies that could live completely away from water. They were the first to develop eggs that could be laid completely away from water. So true land inhabitants, their skin is waterproof. Okay, I said with amphibians we have a semi-permeable skin that needs moisture in order to function for diffusion of gases across that skin. Reptiles are different. If you've ever held a reptile in your hand, you will know that they have very scaly, dry skin. So they have that waterproof skin, and that basically allows them to get away from the water for air exchange. They exchange all of their air through their lungs. They also have eggs with internal membranes rather than external membranes, so they have a chorionic membrane inside their eggs. And they have either leathery or hard shells on their eggs, which allow for these eggs to be laid on land, away from water, and not dry out. So we can get away from water. In the desert, we don't have a lot of water, so it makes sense that potentially there would be a lot of reptiles in the desert. So we're going to look now at what types of reptiles we have in the desert. The diversity of reptiles within our Sonoran Desert is obviously more diverse than what we have with amphibians because they are not obviously tied to water. So there are actually 107 species of native reptiles in the Sonoran Desert. 6 of those are turtle species. We have 49 lizard species and 52 species of snakes. So when you're out on your Sonoran Desert hikes, make sure you keep your eyes open for turtles, lizards, snakes. They're out there. Often it is hard to find them, and we'll look at why that is. A lot of them are very easily camouflaged. A lot of them spend a lot of time in their burrows, in rock crevices, underneath the ground, things like that, but they are out there, so keep your eyes open. Interestingly, of those 52 species of snake, 13 of those are different species of rattlesnakes. I really was shocked at how many species of rattlesnakes there actually are. Arizona has more species of rattlesnake in it than any other state in the United States. So that was kind of interesting to me. Obviously, their solutions to the heat and desiccation, the things we have to overcome in the desert, are also to avoid, escape, or tolerate. This time around, we actually have representatives from the reptiles that are basically escapers, avoiders, and tolerators. So we have examples of each of those kind of techniques allowing them to survive. So first of all, we're going to look at desert iguanas. One thing that they do that's kind of different is they are able to tolerate what we call hyperthermia. So basically their body temperature can be raised by quite a bit, and they are still able to function and do very, very well. I was talking to our resident herpetologist here in our department, and she was saying that she is always surprised when she's out in the field, 110 degrees outside, and there are iguanas running everywhere. The iguanas are the ones that tolerate. Heat does not bother them. Their body is able to tolerate that hyperthermia. Most animals within the desert do not have that kind of heat tolerance. We also have examples of color changing. Okay, this is another adaptation that is particular, well, not even particular to lizards, but advantageous out in the desert. So lizards in particular, this one is a desert spiny lizard. They actually exhibit what is called metachromatism, where they can actually change the colors that are present in their skin. So due to external temperature. So when it's cooler outside, say in the winter or maybe in the evening, things like that, when it gets cooler, they darken up their skin, which allows them to draw more heat from the sun. So black attracts more heat. when it is really, really hot in the summertime, they lighten up their skin so that more heat from the sun, more light from the sun is reflected back in order to control their body temperature. So that's kind of interesting. This desert spiny lizard, I think, is kind of interesting with how many different colors he actually has on his skin. All of these photos in this PowerPoint presentation are taken from our local Sonoran Desert right here, mostly in Maricopa County. So many desert reptiles adapt to the desert conditions by being nocturnal. Okay, I have a video on our week 8, I believe, that shows you the nocturnal life in the desert. The reason that when we go hiking in the desert, we don't see animals running all over the place. We don't see a lot of animals. I have animal hikes for you to do, and I have accepted that you may not find any. Hopefully you do, but I've accepted that you may not, because once the sun goes down and it's dark outside and it is at least somewhat cooler, we all know that during the heat of the summer it stays pretty hot here at night, but at least somewhat cooler, the desert comes to life. So if any of you have night vision goggles, potentially you could go out to the desert at night and look around, and you would see a host of animals running around, getting their food, doing their things. The desert is really alive at night. So many desert reptiles are nocturnal. This is a western banded gecko. He's pretty cute, pretty cool banding there. A lot of snakes as well. They don't so much necessarily thermoregulate by moving themselves back and forth. They do some of that as well, but a lot of exchange for geckos and snakes comes from the ground. So heat from the ground, heating them up, as well as heat exchange from the air, helping their bodies. Snakes obviously do sunbasking as well, but in particular, geckos and snakes are able to exchange heat through the ground and through the air. A lot of reptiles are also diurnal. Generally diurnal reptiles, diurnal means that they are awake during the day, sleeping at night. Generally diurnal reptiles are very well camouflaged. So even though they are there during the day, it is difficult to find them. So you really have to keep your eyes open, be observant, and look around. They actually, diurnal reptiles use the sun basically to regulate their body temperature. By basking in the sun, they can heat themselves up. Okay, so in the morning, say it's been cool overnight, in the morning they come out, they bask in the sun, they heat their body up, they get their metabolism going. If they then get too hot, they move into the shade, and they move back and forth into the sun and the shade all day long, and basically manage their internal body temperature that way by moving in and out of the sun. This is a picture of a greater short-horned lizard here basking in the sun. He's pretty cute too. All right, so reptilian adaptations to the desert. Let's look at some of these. There are a lot. A lot of reptiles avoid or escape. As I said, a few do tolerate. So many reptiles spend long times under the ground, in burrows, but generally these burrows are not dug by them. Okay, generally they are taking advantage of burrows that are dug by other animals, and generally they are looking in these burrows when environmental conditions are poor. So pretty much all summer, except potentially when we have monsoon rains, when it's really hot and dry, they are spending their time underground in burrows. They go through periods of hibernation in the winter. Almost all reptiles go through periods of hibernation in the winter and what we call estivation in the summer. So hibernation is a deep sleep. Estivation is a little bit less deep of a sleep, but generally hanging out. Their metabolism slows down, their digestion slows down, their elimination almost completely stops, and they just hang out and basically wait for conditions to improve. Often reptiles store water and nutrients in their bodies, okay? And they also allow waste to accumulate, very similar to that spadefoot toad, allowing waste to accumulate until conditions improve and they are able to eliminate those wastes. So let's look at some examples here. This is a desert tortoise, super cute, and actually some of the groups of desert tortoises here in the Sonoran and Mojave Desert are actually somewhat threatened due to animals eating them, things like that, predator, prey, human encroachment on their land, etc. So the desert tortoise is actually a very, very good adapter to the desert, and they actually dig burrows themselves to escape those extreme temperatures. Okay, so in the hottest part of the summer, they are estivating, so they're basically sleeping, hanging out in summer, and they are hibernating all winter long until the females come out in early spring and start feeding and getting ready for life again. And the males actually may hibernate all the way through spring and come out in early summer. So interesting. One really cool adaptation of desert tortoises, I thought this was really cool, is that they have very, very large bladders. Their bladder can actually take up to 40% of their weight. So by the end of their hibernation period or their estivation period, they have these huge bladders full of urine, and they don't eliminate it until conditions improve and there's water for them to drink. So until there's available water for them to drink, they won't eliminate these wastes. They are able actually to concentrate the uric acid wastes within that urine, save it as a solid substance, and then reabsorb the water and the ions from that urine and reuse the water and the ions and have an actual solid elimination ability. Interestingly, one fact that I read about desert tortoises that actually somewhat human, it's definitely human caused, but somewhat threatens them is people during the summertime potentially when they actually see a desert tortoise, they'll go out and pick it up. And the reaction of a desert tortoise to someone messing with it, basically being scared, whatever, is for it to eliminate its urine. And because of this, the desert tortoise then has lost all of its reserve stores of water and potentially is going to dehydrate and die. So for sure, never go out and touch a desert tortoise. They are completely protected, unable to be picked up, taken out, disturbed, whatever, out in the desert. They are completely protected. So make sure our desert tortoises are safe. So they can store these urine and waste for months while they're hanging out in hibernation and estivation. Once fresh water is available for drinking during those monsoon rainstorms, then they eliminate those urates in solid form. Interesting. We certainly don't ever pee solid form. And minerals can also be reabsorbed from their shells. When they have not been eating for a long time and they're low on nutrients, they can actually reabsorb minerals from their shells. So these guys are very, very well adapted to the desert. I have some pictures here of little baby desert tortoises hatching out. Their peak activity is in August and September, so if you really want to see desert tortoises out in the wild, then potentially head out during August and September. I know it's still fairly hot, but during August and September, during that monsoon rain system part of the year, if you want to see desert tortoises out in the wild, then potentially head out during August and September. That's when you're going to see the most activity from desert tortoises. And interestingly, every year the number of females that are able to lay eggs has to do with the amount of rainfall that year and with the amount of vegetation that's available for them to eat. So if there's not a lot of vegetation available and there's not a lot of water available, females just won't lay eggs that season. So obviously turtles could get threatened very quickly when there are years where females don't even lay eggs in a particularly dry year. So the young often come out in the fall, but not always. In a particularly dry year, they may actually overwinter in the burrow and not emerge until spring. So it may be almost an entire year before you see those young come out of the burrow, but pretty darn cute. Next, we're going to talk about Gila monsters. I know that everyone has heard about Gila monsters, kind of interesting. You hardly ever see them in the desert. They are there, but they spend about 98% of their time underground, and so the odds of actually ever seeing a Gila monster in the wild are very, very low. They are one of 2 venomous lizards in the world, okay? So they do have a fairly strong venom. Generally, a human being is not going to die from a bite from a Gila monster, but it's going to make you very, very uncomfortable, very, very painful, very, very sick. So don't disturb Gila monsters. If you happen to see one in the wild, don't disturb them because you don't want to get bitten because it would make you very, very sick. These guys are strong climbers and very powerful diggers. So these guys actually do dig their own burrows. 8 months or more of the time spent underground, and it actually may be closer to 10 or 11 months of the time spent underground. They don't spend a whole lot of time above the ground, so once again, they are avoiders or escapers. They do that hibernation and that estivation process. They basically stay away from the heat and they stay away from drying out. If you look at their tails, they have these very fat, stubby-looking tails. This species of lizard is actually able to store fat and water in its tail. So when it's time to go underground, you may see Gila monsters with very, very fat tails, and they actually store fat up and store water up in those tails that allows them to then use the water and those nutrients for the entire time that they're under in their burrow. These guys come in 2 different color forms. I threw both of them on here for you in case you ever do see a Gila monster out in the wild. We have the banded form and we have the reticulated form. So you can see in the banded form on the top, the black and orange actually makes bands across the skin, and in the reticulated form down at the bottom, it's actually more mottled. So you can see not really any bands there. And these 2 color forms are found in different areas of Arizona. So pretty cool creature. Next, we're going to talk about the common chuckwalla. These you see. I have seen these out when I'm hiking on South Mountain. Pretty common to see these. So you may see these out on your hike. Probably, I don't know, one of the lizards that I see more often, not every time I go out there, but more often. These guys also are fairly inactive during the day. They are sunbaskers, so make sure that you're looking at rocks when it's hot, looking at rocks for potential sunbathing lizards. They also have the ability to store fat in their tails for when they go underground into their burrows, and use that when resources are scarce for nutrients. And they actually, kind of interesting, one way that they avoid predators is this species of lizard actually throws itself into a rock crevice and then it inflates its body. So it blows its body up with air and basically wedges itself inside that crevice so that the predator can't get it out. And that's its way of escaping predators, humans, whatever, basically inflating itself with air and wedging it into a rock crevice. So there are interesting color varieties here as well, and I've thrown 3 of them on here for you so that if you're out in the wild and you potentially see these lizards, you will know that they are all common chuckwallas. They actually just have different color varieties. So this one, particularly at South Mountain, if you hike at South Mountain a lot, I saw one of these guys out at South Mountain, and we looked it up. We saw this bright orange carrot-like tail. That is an adult male common chuckwalla, and this particular color variety is only found at South Mountain. So kind of interesting that they have these bright orange carrot tails. Other places other than South Mountain, you may see darker. You may see an orange to yellow saddle on the back, and generally the tail is going to be more of a white to a yellow color. You're not going to see that bright orange carrot tail unless you're at South Mountain. This is a picture of a juvenile common chuckwalla, so you can see stripes on the tail. And no saddle pattern necessarily, more of a full body similar color, but you can see stripes on the tail. So I just wanted you to be aware that potentially you may be seeing the same lizard and that it just looks different. All of these are from areas in Maricopa County. Next, we're going to look at the flat-tailed horned lizard, particularly adapted for sand. These guys actually hide in the sand. So they will hide in the sand, they will bury themselves in the sand, and you'll just see like this little nose and eyes peeking out of the sand. So very, very difficult to find generally during midday. They dig into the sand because a couple inches underneath the sand, it gets cooler. Okay, so they go underneath the sand to avoid the heat, and they also go underneath the sand at night to avoid the cold. So basically, at night, they allow the sand to heat them up, and during the day, they dig further under the sand and allow that sand to cool them off. These guys are not particularly digging with their feet. They're actually using kind of a side-to-side motion like this to kind of dig their way down into the sand. So it has to be fairly loose sand. These guys are not digging into the dirt and potentially digging a burrow. They're more digging into loose sand. And this species actually has lost its external ear openings. So it can still hear, but it no longer has external ears. Evolutionarily, adaptation for the desert, it keeps the sand out of your ears. So basically there's no external opening, so if you're going to dig yourself underneath the sand all the time, you don't want to have sand in your ears. So that's kind of an interesting evolutionary adaptation to this guy. The fringe-toed lizard, very, very well adapted to living in loose sand. Okay, lots and lots of adaptations on this guy. He has these fringe-like scales on his back feet. Okay, so I did a blow-up of his back feet here, and you can see these little fringe-like scales on the sides of his feet. And it is believed that these fringe-like scales actually give this lizard better traction on the loose sand. So I went hiking one time in the Great Sand Dunes National Park in Colorado for an overnight weekend hike. And oh my gosh, don't think I'll ever hike in sand again, because literally every step you take, you fall back half a step. So you're walking twice as many steps in sand. So obviously for a lizard who needs to run quickly across the sand to avoid predators, you want something that's going to help you gain traction and be able to run faster rather than just sitting there spinning your wheels in the sand. Sand can be very, very slippery. So they have these fringe-like scales on their back feet. These guys, their protection mechanism from predators is actually to dive into the sand. So they actually just, boom, dive into the sand, right underneath the sand, and protect themselves from predators. So their body is built for that. You can see that they have this shovel-shaped head, so very pointed head, kind of like an arrow that would go directly down into the sand. They actually have nasal valves on their nose that they can close in order to, once again, keep sand out of their nose. Who wants sand in their nose? They have scales around their eyes that basically keep sand out of their eyes. They have scaly ear flaps. Okay, these guys actually have external ear openings, but they actually have scaly ear flaps that close over their ears when they dive into the sand. And then they also, instead of being kind of rough scales, they have smooth scales. So basically it's like shooting a missile directly into the ground, where you've got that smooth surface, everything is protected from any sand going in anywhere you don't want it, and you just basically dive your missile right underneath the sand, and it works pretty well for them. So kind of an interesting creature, the fringe-toed lizard. And finally, we'll get to a species of snake. Snakes are fairly well adapted to the desert as a whole, but I wanted to talk about this one in particular, the Sidewinder rattlesnake, because they are able to move so easily through loose sand. Okay, this is more of kind of the type of desert where you have loose sand, maybe out on your way to California when you get into more of the western Sonoran Desert and you have those loose sand dunes. This is more kind of where you're going to see these guys. They are adapted to climbing across and up slippery sand dunes. So exactly what I was doing at the Great Sand Dunes National Park, only I was basically sliding down every time I took a step. And these guys can just zip, 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 zip right up the side of the sand dune. And it has to do with the way that they locomote, okay? So the way that they move, they have a specialized locomotion that allows them to move in kind of the sideways direction and basically modify the amount of their body that is touching the sand surface. So that is good for thermoregulation as well as for adjusting how the sand is basically moving underneath them, and they can basically just kind of sort of slide up the side of the sand dune very, very easily. But as far as thermoregulation goes, if they are cooler, they can put more of their body against the sand to suck up that heat from the sand. If they are hotter, they can actually move with only having 2 points of their body touching the sand. So pretty easy, almost really sliding across the surface of the sand with only 2 points touching, which allows them to not soak up as much heat from the sand and kind of thermoregulate themselves better. I also did a little blow up here at the top of the scales that they have over their eyes. You can see those little sort of points coming up over their eyes. They have those raised scales above their eyes, and it is believed that those raised scales actually work as like little sunglasses for them, kind of coming over their eyes and keeping the sun out of their eyes, and also working to keep the sand out of their eyes. So a lot of these reptiles have really interesting adaptations to kind of keep sand out of places that they don't really want it to be, because they're living in sand a lot in the desert, obviously. So that is our discussion of reptiles and amphibians in the desert. If you didn't see your reptile or amphibian talked about, you can certainly use that for your final project. We have to remember our final project is going to be on a species that we didn't particularly talk about during the semester. So if you have a particularly well-adapted reptile that I didn't get to talk about, or a particular favorite reptile, something like that, found in the desert or amphibian, then maybe you can use that for your final project and learn some more about that. So our next lecture will be bird and mammal adaptations to the desert. So I've thrown on here a little kangaroo rat. Kangaroo rats are super, super well adapted to the desert, so we're going to talk about them. And I've thrown on here an owl. Owls, birds, a lot of birds use cactuses as nesting sites, sometimes within the cactus, sometimes building the nest on the cactus, kind of good protection for their offspring within that nest from predators and things like that. So in our next lecture, we will move on to bird and mammal adaptations. Thanks, guys.